So we can just start a new project. And this FTI quoting cost estimating pro is very automated. They do have this wizard on the lower left corner, kind of direct you where to go. I'm going to bring in the geometry first. So I bring in a one up bracket. Then next step, once the geometry is in, we can just look for the next step. So the program separates the part into three different groups: the thickness group, top surface, and bottom surface. We can work with we can just work with any surface you picked except the thickness surface. Then we continue, go to next, define material. We have lots of material to pick. I'm just going to pick this CRCQ. Thickness is recognized automatically. Then we continue, fill up all the trim holes. We can just select all of them and patch them up and continue, go next. Next one, we're going to recognize the part feature. You can generate and edit. I'm going to just use automation generate. Then you can see the program recognize this is the flange, that's the first draw, and then we have the embossment and then extrusion. Yeah, it's right. If it's not right, you can always edit them. Then the next step, we're going to define a draw direction, basically a punch direction. You can select them by all different ways. I'm just going to pick one of the flat surface right here. And that's my punch direction. Then continue, next step, we're going to set up the process. We're not going to create a binder addendum here. So I jump to process setup. This is the conversion of the surface to mesh. And the next step is picking the punch direction. I'm going to use the same vector. Then program going to ask you, are you going to form this part or draw? If you don't know, you just say automatic. Then solve. So this is the calculation part for this unfolding this part. Then we can see the flattened blank. And from here, we can go next step. We can go blank definition. Right here, they give you the dimension of your blank. Then we can just say, okay, you can select you're going to just simply nest it or progressive nesting, or just strip nesting to fix the dimension of the sheet. We're going to go progressive nesting. And right here, the program going to ask you pick a die plane. So I'm going to pick this flat area. So that's my die plane. And this contour shows you the edge, the stretch of the edge of the part. And you can see the blue area is where you can put a stretch web. And the red area is going to move a lot, so it's called difficult. And then we can continue, go to the next step, which is define, select how you're going to carry this part. So this part I'm going to carry with double-sided carrier. And you can specify those dimensions of the carrier. And this will be the nesting utilization with all different angles. I'm going to use the top one, the best utilization. And then I will going to select the stretch web. And then here we can turn on that information about the edge movement. So this blue area is where we can carry. I'm just going to define a solid stretch web. That's the default dimensions. I'm going to make it wider because we can carry this full area. I'm going to make it 40. And symmetric, make it both sides. And you can move it around. You can make it even wider. And then we can just move to the next step. So the next step is going to pick a die plane. And then we're going to select the process settings. So this is just basic information. You're going to feed from left to right, and the hit lines, scrap dimensions, and the trim tolerance, the cam tolerance, all these are default information. Then we can go to generate 2D process. So 2D process is going to be the cutting process. So default, the program say, okay, we can use 3 stations. first station cut off here and then there. Let's just take the default for now. And the next
Hey,
step we go.
hey, Jeannie, before you do that, let's make it interesting. Put those pilot holes in there, and let's so that way you can and show it how it updates, and then we'll go right into the 3D, and then we can move forward after that.
Oh, I forgot about the pilot.
So what we're looking to do currently is what we're showing you today is we're doing a couple of demos. This is the automated process. This is walking through everything being automated through the process. And then what we're gonna show you is more in detail because not everything's going to be automated. You want to put your own personal preferences within the software, and it will show you exactly how to do so.
Yeah. So I went back, put the pilot, and right here you can regenerate. So we regenerate the 2D process, and then the next step is the 3D process. And that's your 3D process. So the first form, and then flange, extrusion. This is the idle station. So all the yellow, this highlighted, these two stations are the idle station. And then we have this piercing, then final cutoff. Then you're pretty much done. We get summary. This shows the 2D and the 3D process. And then this is where you can write out the report. I'm going to select report and write out. This will take a little bit longer. So to export all the information to this extensive Excel sheet. So when this is going, we can look at this sheet, look at this strip, see where we like to change, where is not as good as we like. Right here, we can see this cutoff, this piece, this cutoff piece is kind of have an angle here, which might not be easy to cut. I mean, a curves in. So what we can do is I'm going to back to the 3D so you can see better. So with that the scrap cut with that shape, we can go back and kind of modify this. First, before I go into the modification, I'm going to open this report file. It's almost done. Okay, so that's the report. So in the report, you'll see all this information. We will see the per part cost, and we have all the dimensions of the die size, and then we have the cost breakdown. We can, okay, I'm going to go back to the, yep, right here at the end of the summary, we can also see this cost breakdown from the interface. The summary gives all the dimensions, and then the tonnage of each stage, how many cams of each station, and the shoe, the minimum stroke, all this information. Also, there's a cost breakdown right here and give you the cost breakdown of what design, machining, build, tryout, inspection, and material. And right here on this, for the details, it gave you the detailed information of the detailed component, the spring pad, stroke control, all this. Okay, so let's open this Excel sheet. So this all the page, all the tabs shows the information related with this project. We have the die cost breakdown, the comparison of the different suppliers. I put 3 of them here. And then you can put more different suppliers information. And that's the operation detail. These are the tonnage of the die load of each station and all these informations. Then we have each operation. We have the operation one with the scrap or the dimension of the scrap and boundary location of the scrap, and then all the way to the final station. So let's go back to this. Let's see, we like to modify this part from here. we like to patch up this because the cutting scrap with detailed shape is not that easy. So right here, we can go to edit blank, and then I'm just going to put a straight line here. And then move it a little bit. This is screen based, so you have to fix your view on a fixed view and then modify them. And then say create, it's patched up. Okay. Then right here, we can regenerate. So it's automatically regenerate everything. Now we will see that scrap shape. The scrap will be, okay, so the scrap doesn't have the notch anymore because we cut it down in this station, and that's our scrap. The other thing we can go further into it is the stretch web. We know we just pick a stretch web like that and then run with it. In this software, we can also quickly run a simulation to check the stretch web stress states to see if that stretch web has issues. Right here, we can see it's okay, it's green here, but you do have some split right here and the wrinkle, excessive wrinkle, which means it's not a good idea to have the stretch web all the way to here. I'm going to change this so we can easily just go to this stretch web area, delete this. I'm going to remove it. You can edit it also. I'm just going to remove it and then redefine the stretch web. Make sure it's only in this area. Okay, so once you do that, you can run a simulation for the stretch web. So I'm going to hit regenerate. Regenerate will including the rerun of the simulation and all the 2D and 3D process. So regenerate finished. I'm going to go to this simulation result and then check. And then you can see it's perfect now. Okay, and lastly, on the 3D process, on the 2D process, I'm going to go back to 2D and then say edit. If you said, okay, I don't want 4 stations for the cutting, I like to cut it down. And first, I don't need this idle station. You can just delete it. We can just highlight it and then delete this station. And then for those scrap, you can say, okay, I like to cut them all one time. You can easily do that. You just, right now we cut here first and then here and then there. You can say, I like to cut them all one time. So you can just move them here and move this station here. You can click here or just click on the scrap and move them over. And then these 2 stations are idle now. We can just delete them. Okay. Then we have to confirm this. Yeah, the program going to complain that you have issues. You probably just the die might be weak to cut it that way. Most time the program will take it if it's not far off from what we need. Okay, so we regenerate the 3D process. And then this will be our final operation. So we have, it's not very practical, but I'm showing you this will be our 2D trim and then form and then go up all the way.